right? So today kita akan tengok a type of questions yang governing gas. Okay, untuk chapter 5.1, so we have three kan. We have three things yang kita akan tengok. We have gas, liquid, solid, and then phase diagram. Most of the calculation are coming from gas. Okay, there's gas yang ada banyak calculation. But and then liquid dan solid, just that yang kita perlu explanation je. So saya akan beratkan on gas lah. So untuk gas, mana sini. Untuk gas, we have two type of question. So it's either a question yang straightforward, you boleh apply the three gas law yang saya dah bincang, iaitu three gas law, which is kita ada Boyce, Charles dengan Avogadro's punya law, or kita will have this kind of question yang panjang-panjang and kita akan terus assume dia adalah ideal gas law. Okay. So untuk the type of question yang you guys perlu guna the simple punya law, is either Boyce, Charles or Avogadro, most likely diorang tak akan bagi tahu. Okay, diorang tak akan bagi tahu which law yang you perlu guna. Okay, so we have three laws. The thing yang to look forward to, how do you want to know you nak guna this law and you nak guna which law, right? So untuk Boyce law, okay, laws mana color. Okay, untuk Boyce law, okay, the type of question dia akan bagi tahu dia guna constant temperature. While untuk Charles is dia punya constant is pressure, while Avogadro is temperature and pressure. Okay, untuk formula ni there's no way other than you hafal. It's by hook or by crook you hafal. But don't worry, the equation is not that complicated pun. So untuk Boyce, it just V1 equal P2 2, and then the question untuk the question untuk Charles law is V1 over 1 equal V2 over P2, and Avogadro's law is V1 over N1 V2 over N2. So you want to know which one nak guna, first thing is you tengok apa yang constant. Dia definitely akan bagi tahu apa yang constant. Kalau lah question tu dia cakap, dia tak bagi tahu langsung apa yang constant. Okay? Apa yang constant dia langsung tak bagi tahu, you terus guna PV equal nRT. This is the holy grail of gas law punya equation, which is the ideal gas law. Ideal gas law. Okay, untuk all of the calculation so far, unless it is stated it is real gas, every question kita assume it is ideal gas. Okay? Every question kita assume it is ideal gas unless stated. Kalau dia bagi tahu, barulah kita guna yang real gas. Tapi untuk real gas, soalan dia tak ada yang untuk calculation. Sebab untuk this syllabus, you guys hanya perlu terangkan. Okay. So, let me show you the examples of macam mana soalan lah untuk Boyce, Charles dengan Avogadro. The soalan always dia akan bagi tahu, okay, we have one system, okay, dia akan bagi tahu lah, contoh untuk Boyce dia akan bagi tahu dia punya pressure, dia bagi tahu dia punya volume, and then soalan dia akan bagi tahu dia akan change one of those, either dia change pressure ataupun dia change volume. Okay, Kalau dia change volume, dia suruh cari pressure, like that. That is the kind of question yang kena guna law ni. So kalau charge, dia cuma benda yang sama. Cuma dia bagi tahu volume, dia bagi tahu temperature, and then apa yang dia buat is dia panaskan atau sejukkan ataupun change volume. Contohlah dia change volume, dia change temperature kan, dia sejukkan. Dia suruh cari volume. And you also guess the same lah. Kalau untuk volume dengan number of moles for Avogadros, dia cakap dia keep this constant, and maybe dia change dia punya volume, dia suruh cari apa jadi kat dia punya moles, ataupun the change of number of moles, apa jadi kat volumes. This kind of question are the kind of straightforward yang you boleh terus guna, right? So the first thing, you need to know what is the constant. So you know what kind of law yang you boleh guna, and then you terus buat calculation sahaja. Itu sahajalah. And one thing to take note, okay, the temperature dalam ni semua is in Kelvin, right? Sama untuk dalam ini pun in Kelvin, okay? Semua dalam in Kelvin. Is everything okay so far? Okay ke? Saya nampak korang.
Okay, sir.
Okay. So, kalau you tengok ideal gas law yang saya tunjuk tu, we have R, okay? Ada type something. Okay. So, what is PV equal nRT? So, P is pressure, right? Pressure. V is volume. N is number of moles. R is the punya gas constant, right? And T is temperature. Okay. The only thing you need to make sure is the temperature is always in Kelvin, right? The thing yang now sometimes people get confused is the gas constant. Okay. Kalau you tengok dalam you punya tutorial or dalam any calculation, kalau you guys tengok calculation, sometimes they use different gas constant. Kenapa dia orang use different gas constant? We have two values yang dia orang selalu guna. So we have this and this. Okay. This is all based on you punya value. Okay. So kalau lah you punya value, right? Everything is in SI unit. You belajarkan SI unit dalam physics. Okay. Semua unit standard, which is dia punya pressure is in Newton meter squared, Newton per meter, and pressure is a force over surface area kan, and dia punya volume is in meter cube. Okay, volume dikira volume in meter cube sebab in chemistry most of the time kita guna volume in liter kan. Liter is equivalent of dm cube. Okay, that's aside lah. Okay, and then moles and temperature. Temperature always Kelvin. Temperature is always Kelvin lah, ataupun K. So untuk 0.08206 is the one yang more commonly used, where the pressure is in ATM. ATM tu apa? Bukannya vending machine untuk duit korang tu ATM is atmospheric pressure. Okay, sekarang kita duduk dekat, you can say is sea level lah. Semua kita duduk ni is the pressure is 1 atmospheric pressure is the pressure yang kita rasa sekarang. Kalau you guys siapa yang pernah naik kapal terbang pun belon, korang akan rasa telinga korang macam a bit popping sebelum korang telan air liur tu. Maksudnya dia kurang pressure lah kan. So that is less than 1 atmospheric pressure lah. And untuk volume dia is in liter ataupun in cube. Temperature still Kelvin. Tak ada beza. So itu sahaja. And dia punya unit, okay, unit is in Newton meter, right? So it's in Newton meter per Kelvin per mole. Mana main ni? Okay, per Kelvin per mole, ataupun dia orang tulis Joule Kelvin per mole. Joule per Kelvin mole. And unit untuk gas constant, which is 0.08206, is atmosphere, ATM, then dm cube, and then Kelvin, and then mole per. Okay, is sometimes they also tulis is in ATM. My god, peliknya AI. Liter per Kelvin per mole. Okay, so I explained that. Do you have any question about gas constant? Berapa question ke? Soalan, pertanyaan, kerisauan? Okay. So, kalau you nak tanya, and then nak guna mana satu gas value? Yang 8.31 ke or 0.82 does not matter. What matter is you punya values of pressure, volume, and also apa lagi satu? Temperature must be in the correct one lah. Kalau you guna 8.31, you punya pressure must be Newton per meter and volume is in meter cube. You guna 0.08206, you have to use atmosphere and volume is in liter per dm cube. Okay. But nanti kita akan tengok you will be given pressure in different type of unit, which is in millimeter gram of mercury. Okay, because back in the day, how people measure what was it called? Measure pressure guna a little instrument. Cannot remember the name, but it has a mercury. Dia macam thermometer tu, where the mercury will move, okay, up and down based on the pressure, the surrounding pressure lah, and dia orang kira berapa banyak dia move. That is dia orang denotes as pressure. Okay, so this is the kind of question. Kalau you tengok, okay, kebanyakan question you guys nak dia panjang-panjang just to scare you off, right? Actually, kalau you guys tengok, this first part of the question absolutely mean nothing to you. Okay, it's just bagi tahu. It's like you baca buku, right? Just wasting your time. So the thing is useful is this. Okay, one thing to take note. Okay, to every single question, you must make sure kalau ada equation, chemical equation specifically, you make sure they balance. Okay, that is the first thing you have to do. But this one I don't know this, it is balanced. Okay, and then cakap, what is the volume of N2H2 in milliliter measured at standard temperature and pressure produced if 220 milliliter of NH2 gas measured at 1.2 atmosphere and 25 degree is dissolved in water. So, apa yang you guys perlu buat is, this is, you tulis balik. This is 20 mil. Then, kalau boleh ada ruang So, cara nak jawab dalam exam, untuk senang, you salin balik dia punya equation. And then, dekat bawah tu, you tulis lah. It is at 1.20 atmosphere and 25 degrees Celsius. Okay. So, apa yang dia nak cari is this. This is the thing yang dia nak cari. Right. So, apa yang perlu buat dahululah. So, since the information here, right? This is information yang kita dapat. This is information yang kita nak cari. And we have a chemical equation. To transfer the information, we have to do uh, stoichiometric punya comparison. Tapi untuk cari stoichiometric comparison, we can only compare using moles kan? Only compare using moles. So the first thing that you can do is carilah mole untuk NH2, which is ammonia punya gas. Right? So, untuk cari dia punya moles, apa formula yang you boleh cari? Which is macam hari tu kita ada mass nak cari ke mole semua kan? But now we are involving pressure. Okay? In gas law, a lot of things are very intertwined with pressure. Mana pressure? Pressure. Okay. So, dia tak bagi tahu pun ini is ideal gas. So, we need to assume it is ideal gas. Assume ideal gas behavior. Okay. Kalau dia bagi tahu it's not ideal gas, baru kita assume otherwise. So the first thing is we need to find dia punya moles. So now it's easier because we have new formula untuk cari. So we have PV equal nRT, where N is the moles, right? So nak senang, kita susun dah siap-siap. So N equal PV over RT, right? So pressure kita tahu. So pressure, so this one, kalau you guys tengok, is in atmosphere. So you already know which gas constant yang you nak guna. It's either 8.314 ataupun 0.08206. Obviously this one, sebab this one is dia punya unit is ATM, right? Atmosphere. So the pressure kita guna terus je 1.20, right? Okay. And then the volume yang di give is 20 milliliter. And remember this is kita guna liter, right? Ataupun m cube. So this nak tukar kepada this, milli is 10 to the power of what? Right? It's 10 to the power of 3. So it is equivalent to 0.02 liter. Right, so kita masukkan dia punya volume is 0.02 over, saya ingat, dia punya volume, dia punya volume pula, dia punya gas constant is 0.08206 and darab dengan dia punya temperature. Temperature dia given in 25 degrees Celsius. So it is 25 degrees Celsius. Kita nak jadi ke dalam Kelvin, right? So in jadi Kelvin, untuk exam, there's a two different Kelvin punya temperature yang you boleh guna is either 273 ataupun 273.15. You punya answer will generally accepted both way lah, but just know that this is more accurate. Okay. Sometimes it's okay you nak guna 273 untuk senangkan kira. Tapi kalau lah, sometimes dia akan bagi tahu is 1 degree Celsius is equivalent to 0 degree Celsius is equivalent to 273.15. Tukar. It's 273.15 degree Celsius is equal to 0 Kelvin, right? Negative. So then you have to use negative 2.73.15. But in this one, dia tak beritahu kita boleh guna je 273. So 25 nak tukar ke ni, so dia tambah O tolak. Yes. Tambah O tolak. Tambahkan. So it is the temperature. 298. Okay. This kind of question, the equation is easy. The thing yang soalan dia is not that hard. Tapi apa yang susah is we are changing it to the correct unit. That is apa yang penting, right? So if you calculate this, you should get 9.8144 times 10 to the power of negative 4 mole. Okay, how many banyak kali we have found that kita tak tahu berapa banyak yang kita nak ambil the decimal places. Okay, usually kalau you ambil 4 decimal places tu is more than enough. Okay, because at your stage now, around kalau you ambil 9.81, it is not enough dah. Because nanti you punya calculation, because absolutely bila it involving moles, those belakang punya decimal point really take accounts. Okay, because we are involving a very small quantity. Okay, okay. So kita dah tahu dia punya moles, and then apa yang tinggal is kita buat dia punya stoichiometric comparisons. Is 2 mole of NH3 is equivalent to 1 mole of N2H2 N2H4. So kalau this one is 9.8144 times 10 to the power 4 mole of NH3. So nak buat apa? Remember tak? Kita darab and then bahagi. So it is 9.8144 times 1 over 2. So dapat berapa? Korang kira dapat berapa? Can you cakap? Ada siapa buat calculation tak? Bahagi 2 je. Okay, sangkut tu. Oh, correct. 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 It is 4.9072 times 10 to the power of 94. So in my class, jangan afraid untuk cakap Jangan risau, I tak makan tu. Okay. So, kita dah tahu dia punya moles. Okay. Daripada moles, nak ke, sebab dia minta, mana. Dia nak volume kan? Right? So, daripada moles, nak ke volume, apa kita buat? Okay. Remember hari tu, yang cloud diagram tu is, kalau nak ke mole, kita bahagi. Nak keluar daripada mole is, kita darab. But kita darab dengan apa? Is given here, it is its standard temperature and pressure. So kita darab dengan 22.4 lah kan. So if you nak tahu dia punya, so volume of N2H4, you should dapat is in mole. So dia punya moles 4.907 times 10. Okay, tolong kira untuk saya dapat berapa? Darab dengan 22.4 liter. You should dapat berapa? Berapakah? Cepat, beritahu saya. Keluarkan kalkulator. Okay, ikut 0.0199. Okay. It's okay untuk ambil just 4 decimal places lah. 0.0010099. But this one saya ambil 1, 2, 3, 4, 5. So, saya ambil 5 decimal places sebab because usually you will take around 4 significant figures lah. But remember, this dia punya unit, you darab dengan liter, dia punya unit is liter, right? You tinggal sini, contohlah soalan ni 4 markah, you will get only 3 ataupun 2 marks. Because always remember bawa highlighter untuk question, dia nak in milliliter. So you should tukar balik ke dalam milliliter, which is, and you should get 1 milliliter. So this is your final answer. Is everything okay so far? Okay. If you look at the flow, the thing yang you need to know kalau this kind of question, you always terus tulis ideal gas punya equation. And then the another thing is you need to first thing is you need to figure out which R you nak guna. Because kalau you guna this, semua you have to follow this punya unit. Kalau you guna the second one, you have always guna this kind of unit. But untuk usually senang kebanyakan kita guna R yang 0.08206. Okay? Tapi tak salah. You boleh je nak tukar. Nak tukar yang atas pun. It's fine. It's up to you. Okay? Awak diberi peluang untuk memilih. Okay? So, this kind of question pula. Dia cakap hydrocarbon, octane, which is you punya apa, gasoline tu. So, if 0.09 gram of sample of octane, so it is 0.095. Okay, it's very good. You tengok you punya info, tulis balik dekat equation. Okay, burns completely in O2, and what will be the pressure of water vapor? Okay, dia nak tahu sini pressure berapa in 4.7 liter flask and at 30 degrees Celsius. Okay, habis. And then if the O2 gas needed to complete combustion was in a 4.75. So actually we have two questions. We have one here and one here. Satu dekat this kind of condition and another one is in this kind of condition. So what is the first thing you need to know? Okay, first is tulis dulu P V equal nRT. By the end of this chapter, you should tidur, you bangun tidur pun, mak you kerja, entah ayah you kerja, itu PV equal nRT. Itu je. Okay? Very important. So, apa yang you perlu buat dulu? The first thing is you need to find dia punya moles lah. Because this is equation. You nak pindahkan daripada sini ke sini, stoichiometric coefficient only can be compared using moles. Remember, you compare guna pressure, saya ketuk awak. Okay, so dia perlu cari dia punya moles. Okay. So perlu ke nak guna benda ni? Cari moles. Kenapa kita tak boleh nak guna this equation untuk cari moles dia? Okay, kita the first thing kalau you guys tengok pun kita tak ada pressure, right? Pressure kita tak ada, right? Volume ada, dia ada. Another thing is kalau you guys tengok 4.75 and 30 degrees Celsius ni is not the volume ataupun temperature of octane. It is the volume and temperature, okay, of water vapor, which is here. Is 4.75 liter and 30 degrees Celsius. So you cannot use this, this punya equation untuk cari. Lepas tu alamak, macam mana nak cari the moles of C8H18? Alamak. Remember tak? Mass over molar mass. Okay? Boleh tak cari mass over molar mass? Tolong carikan saya molar mass untuk C8H8. 0.095 gram. Berapakah molar mass untuk C8H18? Kalkulator, mana kalkulator? Tekan. Kalau kalkulator korang tak nampak buruk by the end of matriculation, maksudnya korang tak buat kerja lah tu. Kalkulator saya dah hilang lah semua nombor tu. Saya pun dah tak tahu nombor satu duduk mana. Berapa molar mass of octane? Ada lagi kah plat tu? Janganlah macam ni. No. Okay. Hello. Hello. Dengar ke? Hello. Nak. Okay, okay, good. Tadi internet saya terputus. Tension ke? Okay, Khalid dah kira. Is 114. Everyone else dah kira ke? Jangan tunggu Khalid je buat. Korang pun kira juga. One, 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 four. One, one, four. So, you put your moles, right? And per moles, should dapat is 8.33 times 10 to the power of negative 4 moles. And then you buatlah stoichiometric comparison. So 2 mole of C8H18 should get you 18 moles of H2O. Kalau 8.33 times 10 to the power of negative 4 C8H18. Okay, is you darab and then you bahagi 2. So you should dapat 7.5 times 10 to the power of negative 3 mole of H2O. That is the mole yang you sepatutnya dapat. Yep. So, now, when you dah tahu dia punya moles, barulah you boleh guna PV equal nRT. Okay, you punya holy equation in gas law. Okay, so dia nak cari dia punya pressure, right? Dia nak pressure. So you ubahkanlah siap-siap. Okay, boleh. Kalau you nak masukkan satu-satu and then you ubahkan later. But for me, I prefer untuk ubahkan siap-siap. Senang, supaya senang nanti you punya calculation taklah semak, kan? So, we have two kan? So, add 4 add mana pemadam saya ni? And add pressure equal to 4.75. Apa benda saya cakap pressure? Volume. Okay. So, add volume equal 4.75 liter and temperature equal 30 degree Celsius. Then you just masukkan je lah. So, pressure should equal dengan dia punya mole is 7.5 times 10 to power negative 3. Okay. And then, gas constant, you nak guna yang mana satu? Okay. Since now, kita ada dua kan? So, kita guna liter. So, it's easier nak tukar daripada kalau kita dah guna 0.08206 sebab it's already in liter. So, kita gunalah yang itu. Is 0.08206 and then dia punya temperature, remember is always in Kelvin. Kita tak lari dari Kelvin. Okay, dia tak state pun dia nak dalam the accurate temperature, so you boleh guna 273 and then dia punya volume, okay, is 4.75. Then you should dapat dia punya pressure. And then untuk the second one is at V equal 4.75 and then temperature equal 22 Celsius. Tolong kira and bagi tahu saya dia punya jawapan. P is 7.5 times 10 to the power negative 3, 0.0826. But now the temperature is different. It's 295, right? Over the volume is still the same, 4.75. The answer should dapat berapa? Berapakah answer? Jawapan anda? Mana dia bagi jawapan tak? I'm still waiting for your answer. Yes, Josh. Let's go. Bagus kan, Mak? Bagus kau. Okay, so, kita dapat 0.039 and lagi satu punya jawapan. Siapa orang lain pula? 0.0393, yes. Okay, the second one. Okay, dia cakap, if the O2 gas or oxygen gas needed to complete the combustion was contained in 4.75. Oh, yalah. Okay. So, untuk this, salah This one salah ya. Sebab kita tak guna 0. Ni, okay. Thank you for pointing that out lah. Okay. So, untuk this, nanti saya akan bagi you punya solution. Because, apa yang you perlu buat is, you perlu cari dia punya, apa ni? Moles of O2 lah. So, cara you nak cari, so ini salah Sorry ya, thank you ya bagi tahu. So, temperature betul, tapi cara nak cari is this is 25 moles kan. So, you buat stoichiometric comparison 2 moles of C8H18 dengan 25 moles of A2. You dapat the moles of oxygen punya gas, you boleh cari. Okay, tak apa, itu you buat dulu, nanti saya akan bagi you punya jawapan, which is untuk the second question is 0.053 atmosphere. Okay. Kenapa dia punya pressure is unit atmosphere? Okay. Macam physics, in chemistry, unit juga penting. Unit, kita have atmosphere sebab dia guna this. Remember tak? This punya gas constant, dia punya pressure is in atmosphere punya unit. So, kalau you tak tulis unit, you may lose 1 marks. Which is, in the grand scheme of things, 1 marks take quite a lot from your total marks. Okay. Okay, so untuk yang ini, untuk yang question number 2 ni, okay, you punya moles, you should dapat is 0.0104. Okay. From the moles, bila dapat, you masukkan balik dalam ini, and then the gas constant still the same, temperature pun sama, and then volume pun sama. So, you punya value of the pressure should dapat 0.053. Okay, thank you for pointing that out. Okay, any question ke? Ada soalan? Oh, kita nak teruskan to the next question. Ya ke? Saya dah terputus lagi. Okay. So, we have two answer. Untuk this kind of question, you punya jawapan akan jadi a bit messy kan? So, what I like to do is I use hash mark untuk tandakan my jawapan. So, this is the first, and this is the second. That's all. Okay. So, let's go on to the third punya question. When an evacuated glass vessel containing weighing is this, so the glass vessel is this much, and then it was filled with unknown gas, Y, and the pressure was this kilonewton per meter at 31 degrees Celsius, and the mass was 137.28 grams. The glass vessel was then filled with completely water, and the mass is 1067.9 grams by using ideal gas equation. Okay. Kadang dia tak cakap pun, you still guna ideal gas. Okay. Determine the relative molecular mass of gas Y. Okay. You nampak je ideal gas equation, terus PV equal nRT. Okay. Untuk this, right, apa yang you need to do, okay, I ada buat pasal density kan. But now, kita need to modify this equation untuk kita cari molecular mass. Okay. You tak modify pun tak apa. You buat satu-satu. But kalau kita modify, cepat sikit kita punya kerja. So, macam mana nak cari dia punya molecular mass? If you remember, N is equivalent to mass over molar mass. Right? Betul tak? Okay. So, it makes sense untuk PV equal N over molar mass RT. Kan? So, it makes sense tak kalau kita nak kumpulkan balik semua, jadi sebab kita nak cari molar mass. We should have molar mass is equivalent to M ni. So M RT over PV. So this is dia punya formula kita boleh guna. So apa yang kita dah ada, right? Gas constant kita always ada, right? Always in our pocket, so don't worry. So the temperature dah diberi 31 degrees Celsius. Pressure dia ada bagi ke? Dia ada bagi 99.3 kilonewtons per meter cube. Per meter square. I'm sorry. And then volume. Mana satu? Volume. So volume kita ada ke? Gas biasa. Kita tak ada ke volume? Do we have volume? Kita tak ada. Right? So volume tak ada. So the two things yang kita ada, mass kita ada tak? This, and we have this. So mass relatively kita can cari. Also kita boleh cari. So now our job is trying to fill in this to make our calculation possible. Okay. Since kita mass dulu atas, kita carilah mass dulu. So mass of gas. Okay. Kita boleh cari. It is simple enough because it's just the evacuated vessel, maksudnya empty vessel lah, tolak dengan bila kita dah fillkan dia. So mass of gas X is equivalent to 137.28 grams minus 134.74 grams. So you should get, you punya is the mass of the gas is 2.54 grams. Okay. But now, macam mana pula kita nak cari volume of water? Okay. The volume lah basically. The volume of the vessel. Volume of vessel. Okay. Macam mana nak cari? So, kalau you baca balik, mula it is empty, right? And then kita masukkan gas Y. Okay. And then it was filled completely with water. And then kita masukkan H2O sampai dia penuh. So maksudnya at the end, this glass is filled with water. Okay. So kalau you perasan untuk you punya experiment 4 yang masa kita buat pre-lab tu, ada this kind of question. Kenapa dia masukkan dengan water? Right. So actually from the water we can boleh cari volume of vessel. So macam mana nak cari volume of vessel? Okay. First we need to know, okay, this is take note because diorang takkan bagi tahu, but the density of water usually, density of H2O usually is equivalent to 1 gram per mole. Okay. That's the density of water. Okay. Water is the benchmark of all of the density. That's why kita start dia dengan satu lah, 1 gram per milliliter. So, if kita tahu dia punya mass, kita boleh tahu dia punya volume lah kan? So, macam mana tahu dia punya mass of water? Okay. Mass of water is, kita ambil dia punya total mass, tolak lah dengan mass of the empty vessel. So, mass H2O should equivalent 1067 0.90 grams minus dengan 134.74 grams is equivalent to 933.16 grams. Okay, kita dapat dia punya mass. So density is equal mass over volume, kan? So kalau lah mass dia is dia punya density is 1. Saya ingat pula 1 saya. 1 and then dia punya mass is 933.16. Okay. Boleh cari tak dia punya volume? Berapa dia punya volume? 933.16. Oh, dia punya volume. So, you should dapat dia punya volume is equivalent to 933.16 milliliter. So, you dah tahu dia punya the total volume of the flask, the vessel. You dah tahu dia punya mass. Boleh tak cari molar mass dia? So, kita ambil sini, kita masukkan je balik. So, molar mass equivalent dengan mass dia is 2.54 grams kan tadi. And then R, kita nak guna R mana? Okay. So, untuk R, you boleh guna dua-dua lah. So, how about kita guna 8.31? So, let's tukarkan daripada 8.314 and then temperature always Kelvin is 304, right? And then pressure is already Newton per meter kan, sebab ini is pressure dia is Newton meter kan. So it is 99.3, tapi remember dia ada kilo, so kilo is 10 to the power of 3 and then dia punya volume is in milliliter. So daripada milliliter ataupun kita perlu nak tukarkan kepada meter cube. Sebab so cara nak tukarkan, mana calculator tolong tukarkan milliliter ke meter cube. So this is equivalent to 0.933 m cube. And then kalau decimeter is 10 to deci is berapa? 10 to the power negative 1 kan? Tapi it is cube. So it is 10 to the power negative 3. Betul tak? Kan? So, dia punya molar mass, apa yang you dapat? Dapat tak? 69.33 gram per mole. Everyone dapat ke? So actually this kind of question is a lot like physics, where you need to do a lot of mental gymnastic on tukar dia punya apa benda tu, dia punya unit. Okay, but it's okay kalau you tak nak guna 8.31. Okay, it's okay, you guna 0.08 tu, tapi you kena tukar this dalam atmosphere balik. Okay, boleh aja. I think we have time for one more question. Okay, so untuk I will discuss one more question. The last question nanti I buat video, I upload lah. So korang boleh go and have a look. Okay, everyone okay so far? I think this is one of the more heavy question yang sebab dia ada banyak calculation kan. But don't worry. Just remember this. This is you punya note yang okay. This here yang gas constant value ni You take note and remember which one is this. To be honest, you tak remember, tak apa. Dia dah diberi 0.8 ni is dia punya unit is ATM dm cube. So kalau dia punya unit is in atmosphere dm cube or liter, maksudnya semua calculation dalam tu perlu guna atmosphere and this lah. Okay, the thing here is just to choose the correct one. By the correct, it means the easiest for you. Janganlah kalau question tu dah beri semua dalam Newton meter, Newton per meter square, and then volume pun dah bagi meter cube, you nak guna juga ni. Tak ke buang masa you nak kena tukar ini ke sini balik, ini ke sini balik. Itu sahaja. Okay, just you tengok pressure and dia punya volume. Okay, so kalau you tengok tadi yang kita buat tu, cara nak cari volume vessel tu is called water displacement method. Okay, remember, I don't know you belajar ke tak dalam sains dulu, yang kalau kita nak kira volume, kita letak air, kan, kita letak air, and then you letak benda tu, boop. Lepas tu berapa banyak air yang melimpah keluar tu, itulah volume yang tenggelam tu, kan. So the same thing yang kita buat dalam chemistry, where kita tengok this vessel, kita tak tahu berapa, kita fill in water sampai penuh. So berapa banyak water yang diguna dalam ni is equivalent to dia punya volume. Walaupun kita tak tahu berapa banyak kita isi, by the weight, kita boleh assume, because density of water is 1 gram per 1 gram per milliliter. That's the density of water. And we are usually only using water lah, because density dia paling senang. So, 128 milliliter of oxygen was collected from the decomposition of potassium chloride at 24 degrees Celsius at atmospheric pressure of 1762 millimeter mercury. This is the one yang saya cakap, another yang dia orang suka guna pressure punya unit, millimeter mercury. So, jangan risau. This millimeter mercury usually akan diberi dekat korang punya ni lah, question. It's either given here dekat question here, ataupun dalam you punya tutorial, dalam you punya question book dekat depan. Ini mana hala kau. So, nampak tak? Pressure here. So, pressure, 1 atmosphere is equivalent to 762 millimeter mercury ataupun 760 torr. Torr is another unit of pressure but rarely used. So, yang kita selalu guna is kilopascal ataupun newton meter. And remember from physics, Pascal is equivalent to Newton meter lah juga, kan? Because it's another unit of measurement. Okay. Remember, the reason why kilo, nampak tak, is ada 0.325. So this is the unit measurement. Cara nak tukar dia jadi balik ATM. So don't worry, dia orang akan bagi. Alright. So and then the vapor pressure of water is 24 degrees Celsius was 24 milligram. Alright. So, apa yang kita perlu buat? So, this is where you should apply the Dalton laws of partial pressure. Where P total, the total pressure is equivalent to the pressure of dia punya non-reacting gases. So, we can assume that oxygen gas does not react with the pressure of the gas from water. The gas of water. Okay. Water bila kita heat does not mean dia jadi oksigen dengan hidrogen. It's still water molecule but in gaseous form, kan? So, kita nak tahu dia punya So dia nak the mass of oxygen, right? So untuk tahu mass of oxygen, kita perlu tahu dia punya pressure of oxygen lah, right? And remember, kalau dia tak bagi tahu apa, we always assume it is ideal. Okay. So dia nak tahu mass, kita boleh tahu daripada moles kan, which is kita dah buat tadi. Which is PV equal mass over RT over molar mass. So mass is equivalent to PV PV darab dengan molar mass over RT, right? Saya cuma ubah aja di sana, then this one pergi sana. So kita nak tahu dia punya pressure, kita tak tahu. Volume kita boleh tahu 128 milliliter. Molar mass kita obviously tahu oxygen gas, right? Kita boleh cari gas constant and then temperature. Temperature pun sudah diberi, right? So temperature is 24 degrees Celsius kan? So first thing is kita need to find dia punya pressure of oxygen. So pressure of oxygen is equivalent to pressure total minus pressure H2O. So pressure total, mana satu pressure total? Pressure total is 762 millimeter. 762 millimeter mercury minus dengan dia punya pressure of water is 0.4 millimeter mercury. So you should dapat 738 millimeter mercury, and cara nak tukar dia balik ke atmosphere is you darabkan dengan 1 atmosphere over 760 millimeter mercury, and you should dapat 0.971 atmosphere kan. So you dah dapat dia punya volume, dia punya pressure dah dapat, volume dah dapat, molar mass dapat, gas constant you boleh pilih, temperature pun dia dah diberi. So teruslah cari, simple as that. So mass is equivalent to dia punya pressure 0.971. Dia punya volume, okay, remember this is milliliter, tukar kepada liter. Okay, the liter is 0.18, and then molar mass of water is H2 dengan O, so dapat 32 over RT. So R sebabkan saya guna liter tadi, so I use the 0.08206. Okay, and then darab dia punya apa, temperature, which is 24 degrees Celsius. Nak tukar ke Kelvin, you just tambah 273, then you should dapat 297. So the mass that you should dapat is 0.163 grams, right? So just remember that the total partial pressure should equal the total pressure. And one thing is, other than here, that saya dah point out that dia punya mole fraction, okay, contohlah mole fraction O2 plus mole fraction of H2O should always equal to 1. That's another way kalau nak cari mole, because it is a mole fraction. It is a fraction of here campur here 1. Okay, untuk soalan yang last, kita tak sempat nak bincang, but I'll do a video nanti I upload later separate, and I can bincang later lah. So far anyone have any question?
Sir,
Yeah.
yang 32 tu molar mass siapa punya?
Water.
Water.
Yes. Water pula. One, two, three. Oxygen. Sorry Oxygen. Sorry. Saya silap. Bukannya water punya molar mass. It is oxygen punya molar mass. Sorry because O2 we have 16 plus 16 gram per mole. Sorry. Thank you for pointing that out. It is the molar mass of oxygen. Okay? Okay ke? Okay ke? Okay ke? Kurang ada ke lagi? Okay. Auto. Okay, it is an oxygen because we are calculating the mass of oxygen. Sorry Everything okay ke? The last question nanti saya akan upload a separate video untuk if nothing, kita boleh masuk ke Discord ambil attendance.